Hi guys, welcome to the 5.4 through 5.7 practice test solutions, and hopefully you find this practice test solutions helpful and it prepares you for the real test coming up. So let's get right to it. Alright, so hopefully for number one you got this red image here made from the black preimage. So just to show you how I got it, we just took each point and we translated it to the right 4 up. So this whole triangle has been shifted to the right, 4 up. One thing I do want to emphasize on your test is you need to put your prime symbols in the right place. So just putting a red triangle here or any triangle, even though it could be the same triangle in the right place, it won't be full credit unless you put your markers on there. Alright, so here's number 2. Again, all we did is take this triangle and translate it or slide it. So I just slid each point 3 left, so 1, 2, 3, and 1 unit down. So each point got slid 1, 2, 3, and 1 down. Again, I've correctly labeled the points with primes, and we should always get exactly congruent figures here. Okay, so number 3 asks us to identify the translation that moves the point to the origin. Well, the first thing I need to do is I need to go to the right, because the origin, I'll just kind of show you in green, this point right here is the origin. So if this is our point P and we want to move it to the origin, this would be our point P prime. The origin is just the center of the graph. Okay, so what do we have to do? Well, we have to do 1, 2, 3, 1, 2, 3. So we need to go 3 left, 3 left, and then what do we have to do after that? We have to go 2 down. So, 3 right. It'd be nice if I knew my right and left. So we need to go 3 to the right. Sorry about that. It's early in the morning when I'm doing this. Haven't had my second cup of coffee yet. And then we go 2 down. 3 right, 2 down. Alright, so don't make the same mistake I did there, guys. 3 right, 2 down, and you would just put it right here. 3 right, 2 down. And that's the translation that gets you from point P to the origin. Okay, on number 4, it wants to know the translation that got you from the preimage to the image. Remember, our preimage doesn't have primes, our image does. So we want to start with one of these points here and see what it takes to get to that point down here. Alright, so you can do all of them, but I'm just going to do 1 point. So I just decided to choose H. And what I'm going to do is I'm just going to figure out how many moves it took me to get from H to H prime. Well, the first thing I notice is I'm going, let's see here, I'm going right 6. 1, 2, 3, 4, 5, 6. So I'm going 6 right. Pretty easy there. And then I have to go 6 down. So I need to go 6 down. And notice we always usually do the right and left first, and then we do the up and down. Because remember, when we graph a point, we always graph the XY. We always start with the X movement, and then we go to the Y movement. X is side to side, Y is up and down, and so we kind of think about that same way when we do a translation. Alright, so 6 right, 6 down. Alright, number 5 says a triangle is translated 5 units right and 2 units up. Then the image is translated 3 units left and 8 units down. Write a translation of the original triangle to the ending position. Now, I didn't make an entire triangle. I just chose one point. And it doesn't matter. You could make an entire triangle, but each one of those points are going to follow the same rule. So to keep it simple, I just used a point. Now, this is P. I called it point P, and it's my preimage because I don't have any primes. And then I just followed what they did at first. So what did I do here? I went, if I started here, and you can start it anywhere you want. I started it over here so I knew I'd have enough room to just keep it on my graph. So I just randomly chose P right here, and I went 5 right, 2 up, and that's going to be P prime. But you don't want to stop there. Then it says you go 3 units to the left, and then you go 8 units down, and you'll get here to P double prime. Now, it's asking, write a translation of the original triangle to the ending point. So I don't really even care about this P prime anymore. Now I just want to know what's the translation that gets me from here to here. I use this point to kind of get to the middle, but now I just want to know what's the translation between the image and the double prime here. Well, that's pretty easy. It looks like we go 2 to the right, so we go 2 right. Sorry for the messy handwriting here, I'm using my mouse. And after that, we go 2 to the right, and I think we go 6 down. 6 down. And again, we just ignore this middle point because we only want to know from the first one to the last one. Okay, so for number 6, we want to reflect this figure right here, triangle PQR, over the x-axis. So we want to flip it down into the, it looks like we're starting in the first, then we want to flip it down into the fourth. So what's the rule when we reflect over the x-axis? Well, we keep the x values, so I kept 2, 5, and 1 just the same, and then I just switched the signs on the y values. That's the rule for reflecting over the y-axis, reflecting over the x-axis. So when I do that and keep the first x values the same, switch the y's, it just simply flips that triangle down into the fourth quadrant. Okay, so for y-axis reflections, what we do is we keep all our y values the same. So 2, 1, negative 2, negative 3, 2, 1, negative 2, negative 3, and then we switch the signs on our x value. Negative 3, negative 1 changes to 3, 1, 1, and 3. So negative 3, negative 1, and negative 3 changes to 3, 1, 1, and 3. Graph it, and you can see it simply just gets switched over the y-axis. Oh, number 8's pretty easy because we look at it and say, is this a reflection over the x-axis or the y-axis? Well, it looks like it got, and here's the pre-image, and it got flipped up. So we're using x-axis is our line of symmetry. So it's definitely an x-axis would be our answer. X-axis. That's next. Alright, number 9's pretty easy as long as you know the rule. Remember, we're reflecting over the x-axis. Well, keep all of your x values the same. So 1, 4, and 6. That's a 6. And then switch the signs on all of your y values. So negative 1 becomes 1. 2 becomes negative 2, and 6 becomes, negative 2 becomes positive 2. So your coordinates are 1, 1, 4, negative 2, 6, positive 2. Okay, so for number 10, it's basically a double transformation. We start with a translation where we go 1 right and 5 down, and this would be A prime, B prime, C prime, and then we reflect it over the y-axis using our y-axis rules, and there it is. This is what you need for this problem. So take a look at it and see if you have any questions how we got that. Okay, so now we're looking at rotating 90 degrees counterclockwise about the origin, and we want to label our new points. Alright, so let's see what we got. So what's the rule when we do a 90 degrees counterclockwise rotation about the origin? Well, we swap x and y. So 3 comes first, 2 second, 1 comes first, 2 second, 1 comes first, 5 comes second, and then we change the sign on the new x value. So when you do that, it'll rotate it around. We notice we are turning this thing around like that in that direction, and that's how we do it. There's a little arrow here. So we're rotating it 90 degrees counterclockwise to the left. Okay, so what's the rule when we rotate 270 degrees counterclockwise about the origin? Well, what we do is we swap the x and y just like we did over here on number 11. But then what we do is we change the sign on the new x value, right? So let's see here. No, sorry, new y value. My bad. So we swap them, and then since this negative 2 became a positive 2. We swap them. This negative 1 became a positive 1. We swap them. Let's see here, this negative 1 became a positive 1. We swap them, and this negative 2 becomes a positive 2. And so we graph it, and we can see that it got turned around 270 degrees, almost, what, 3/4 of the entire circle. Okay, for number 13, all we want to do is a rotation of 180 degrees about the origin, counterclockwise. So what happens? Well, you just switch all the signs. That's all you do with 180 degrees. So all these signs just get switched. 2, negative 3 becomes negative 2, 3. 1, negative 2 becomes negative 1, 2. 5, negative 2 becomes negative 5, 2, and 4, negative 3 becomes negative 4, 3. Graph it, and it gets flipped around over, or turned around, not flipped, but turned around over here from the 4th quadrant to the 2nd quadrant, and we're done. Okay, so now I'm doing number 14 here, and it gives me 3 points, and with no graph, we just want to rotate 90 degrees counterclockwise about the origin. So that's pretty easy. So the first thing I'm going to do is I'm just going to swap x and y. So I will put the 2 first and the 1 first, and then with 90 degree rotations counterclockwise, we just change the sign on the new x value. So that'll be negative. So I'll put my negative up there, 2, 1. And then again, we'll just switch 2 and 4, and then we'll make this 2 a negative 2. Hopefully you can see that's a negative 2. And then we'll switch the negative 3 and 1 but since we changed the sign on the -3, that's just going to be +3, comma 1. And those are going to be our coordinates of our 90-degree rotation, counterclockwise. Okay, so number 15 wants to know, why is it not necessary to use the words clockwise or counterclockwise when rotating 180 degrees? Well, think about it this way. If you're rotating 180 degrees counterclockwise, it's going to rotate over here, and all it's going to do is switch the signs. That's our rule. So that is going to be -3, comma -2. So that's 180 degrees counterclockwise. But if you do a clockwise, that's no big deal. Then you would just go 180 degrees here, but you come to the same place, because 180 degrees is just kind of a half circle here. So you get on a half circle, you get to the same point. Whether you go left or you go right, you're still going to end up at the same point. So you're going to end up at the point -3, -2, whether you go left or right, because it's just a half circle. So I'd say something about a half circle of rotation there. Okay, so for dilations, they're really pretty easy, especially if you write down the coordinates. So what I did is I wrote down the coordinates of R, which is -1, 1, and S, which was 2, -2, and T, which is -1, -2, and then you just multiply by the scale factor. So all of this stuff just got multiplied by 2, because I had a scale factor of 2, and then I graphed it. So that's all you have to do. Alright, again, all I did was just copy down the coordinates of the preimage here, L, M, N, O, and then I multiplied by a half, and when you multiply by a half, you just simply divide everything by 2. So I divided everything by 2, and I actually shrunk my shape here, and it looks like this blue one here. So that's what we'd be looking at with number 17. Notice, guys, I labeled my new points with primes. Don't forget to do that. Alright, so for number 18, it says the vertices of the triangle A, B, and C are those points. The image has a coordinates of A prime is 3, 6, 12, 6, 15, 9. What is the scale factor of the dilation? Well, let's just look at A. We don't need to look at all the points. Let's just look at A to A prime. So what's the multiplier that gets you from 1, 2 to 3, 6? What do we multiply these numbers by to get these numbers? And we multiply times 3. So the scale factor would equal 3. And that's all you have to do. That's easy. Alright, how does the area of the triangle in number 17 compare to the original figure? Alright, well, let's go back and take a look at 17. Now, I had to fix 17. It wasn't halfway in between. It went all the way to here. So let's take a look really quick. Well, how long is it from here to here? Well, I think that's 3.5 or 3.5 from here to here. And I think this from here to here is 3. So 3.5 times 3, I believe, is 10.5. So the area of this guy right here is 10.5, the smaller one. Now the area of the bigger one, let's see what that is. That is going to be 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6. So 7 times 6, that's 42. I'll just put it here. Okay? So let's go ahead and make a fraction out of that. Well, and before we make a fraction out of it, I just kind of said, okay, 10.5 times what scale factor equals 42. So what factor of 10.5 equals 42? And again, like we said before, we'll just divide 10.5 both sides, and let's see what we get. Alright, so here's how I look at it. I said, well, when I do this math right here, I see that the preimage is 4 times larger than its image, which means that the area of the image is smaller, so it's 1/4 the preimage. So this would be the answer to the question. It's 1/4 of the preimage, or 0.25. You can think of it that way. And the last one, it says, describe the difference between the images of the dilation and the image of the other 3 transformations. Well, the other 3 are what we call rigid transformations, and this is a little therefore arrow. So therefore, they remain congruent. They don't change. Now, a dilation size changes. So the shape stays the same, but the size changes, and that's the big difference with dilations. Okay, so we are done. Have a good day. Good luck on your test. See ya.